So what we're going to do is carry on looking at being able to solve equations, these linear equations, okay? But remember, what we were doing before is finding x. So a particular equation had an answer like 35, so we went through and undid it all. Understand that? So remember, we did lots of it where if we know what x was, we got an answer at the other end.
So we didn't do the pink thing, the thing that you just showed.
Yeah, we did.
No, we did this number one. Like,
Yeah, we didn't do that one.
Yes, we did.
and I think you just wrote it and then you put to next time.
Yeah, that was what we did. No, this is what we did because next time, this is what we're doing now. We did do that, but maybe you didn't write it down. But we did this one. It's the same thing with brackets or not. But what we had before was that the answer. It was an answer. So this, an x goes in, and a number comes out, right? And that's how I think right from the beginning we had that whole solving linear. So what x gives an answer of y, and what that led to, for instance, was if you have something like x plus 1, we could plot points. So if we have function x plus 1, y equals x plus 1, we would say when x is 0, y will be 1, because it's 0 plus 1. So we could put a point here, okay? And if I say x is 1, x plus 1 will be 2. So I'd put a point at 1, 2. Okay? And if x is 2, x plus 1 will equal 3, and so on. So what we then noticed was that if we had those points, we could draw a line, and therefore y equals x plus 1 would go through those points. So that's our line, yeah?
Oh, I remember this. We did this.
Yeah. Yeah, we did it before. So you plot the points, you draw the line. We've done it this time.
Where we did the huge triangle, remember?
No, didn't we also do didn't we use this when we dropped that new thing from the...
Well, we did what, sorry?
Well, the elastic, how many elastic we needed.
Oh, no, that was scatter plots. That was something different. Now, this one is a function where the points lie exactly on a line. Now, you've done it this time where you work out the x and y that go together, yeah? And we plot the line. Now, you've also looked at the gradient. So the gradient of this line is?
Y equals 1x plus 1.
And the gradient is?
1.
1. Okay? Now, if I said to you, solve x plus 1 equals 5, what would you say?
Where x plus 1
So using the graph, how would you solve x plus 1 equals 5? Sophie?
Well, the line would have to go through 5.
Yeah.
And the gradient would be 1.
Well, hang on. So if we do x plus, this doesn't work very well, x plus 1, that's this line. If I want to know where it equals, it's rubbish, isn't it? 5. What would you do? So we can do it algebraically now, but how would you do it on the graph?
Wait, we learned though that the intercept is 1.
Yeah, but I think what we're doing, you're taking a step back. So the intercept is 1.
And the
gradient is 1. No, the gradient is 1. But I want to know, do you remember back here, look, using this method up here, if I said to you, solve x plus 1 equals 5, what would you do? So first thing you would do is
5
minus 1 from both sides, leaving you with x equals
5.
4.
Right, 4.
And that's it, yeah? X is equal to 4. Happy? But what I'm asking you now is, if we have the graph of x plus 1, so this graph is y equals x plus 1, how can I show on the graph where does x plus 1 equal 5? This is an important bit. How would I solve x plus 1 equals 5 using the graph?
Well, because the y-intercept.
Isn't
No.
it minus 1? So you
Oh, I know!
Go on.
Because it goes like it's a straight line going. It's vertical because there's no y equals. It's x.
No. This is the x. You're getting confused with lots of different things. I think. What I'm saying is, all right. Let's go back, all the way back up to the top. Come on, computer. You're going slow. Right. Is it going to work? Stop recording. So take you back. So here is the function, 3x minus 4. And we have to draw the line. How do we find the points? So
Well,
this is the x.
0 is minus.
0 is minus 4. Now, here's the thing. You're giving me shortcuts now, which is fine. But you have to remember that 3 times 0 minus 4 gives me minus 4. 3 times 1 is 3. Minus 4 is minus 1.
But
3 times 2 is 6. Minus 4 is 2. Now, we know a shortcut, but I'm going to stop you using the shortcut because you've forgotten what it actually means. So 3 times 3
is 6.
9
Oh, minus 4 is 5.
is 5. 3 times
4 is 12.
minus 4 is 3 times minus 1 is
minus 3.
minus 4 is.
Minus 7.
So here's the thing. If I then were to use this graph, minus 1,
Minus.
well, I'm going to go for 0. I need to zoom out a bit. Right? So, minus 1 is minus 7. So on my graph, here's the thing. Minus 1 is minus 7. 0 was
4.
minus 4.
Oh.
1 is
Minus.
minus 1. Okay? Just to remind you. 1 is minus 1. 2 is 2. 3 is, now notice what we're doing. 3 input, 5 output. 4 is
input,
8. So 4 gives me 8. Okay, here's this. So then, what we then do is draw our line.
Oh, and then you see how much it goes into.
So we draw our line like this. Okay.
Yeah.
Now this is the line. Y equals 2x, 3x minus 4.
Yeah.
So if I said to you, solve 3x minus 4
it'll be
equals
0?
5.
Wait.
What would you do?
Oh, 3, 5.
So 3x minus 4 is when x equals
3
3.
and y equals 5.
Y equals 5, yeah.
That's it.
Oh, so sorry, I didn't understand the way you right. Sorry.
That's all right. So what we then do, if I want to solve 3x minus 4 is 5, I can either do it my algebraic way, or on my graph, I can go to 5, read across to where it hits the line, and then come down, and that's my answer.
Which way would you like us to do it?
Well, I want you to be able to do both. That's the thing, you need to understand both. So here's the thing, so if we go back
We
to
stopped recording.
here,
We're not recording anymore
we are.
because you stopped.
So on this one, if I've got the line
So this.
x plus 1 equals 5, I tell you what, let me, maybe it's easier to do copy paste. Let's do
Wait,
page.
can you.
Let me, if I just put it over here.
I know what it is. I think it is.
Whoa.
You know what it is.
You know what
You know
it
it
is.
is.
Yeah.
Right, so if I say to you now, where does x plus 1 equal 5? And here's the graph of y equals x plus 1. Millie, what do you do?
X equals 4.
Because,
Go from the 5 to
exactly, so we go to find the 5,
Yeah.
we read across, I'm going to use
where it
this,
hits
to where it hits the line.
You go down and it comes to 4.
Exactly. Then we hit
Oh, that's
And
so
there.
clever. Wow.
Okay, so there's the solution. Alright?
They are perpendicular. Is there a meeting?
No, there's nothing perpendicular. Oh, that one and that one are
At a right
perpendicular, yeah.
angle.
So we would say, if I went to solve x plus 1 equals 5, I would say x equals
4.
4. So we did it algebraically, and now we've done it graphically.
So wait, then when we put 4 plus 1 equals 5, would that be?
So that's just another way of doing it, isn't it? So if I said to you now, using the graph, solve x plus 1 equals minus 1.
Wait, where's x?
Jaina?
0.
0, you think?
Isn't it minus 2?
So where's the minus 1 relates to the which one, the x or the y?
Wait.
The y.
Yeah, it's x and y.
So we have to go on the y
And then you
and
go
look for minus
down
1.
to
Yeah,
minus 1.
1.
So we then go
across.
across to the
So
line.
It's minus 2.
Oh, done the wrong thing there. Right, so yeah, we go.
Oh wait, no, is it? Yeah, I think it's minus 2.
Yeah, so we go across from here, across to the line. And then when we get to the line, the next thing we do
Go
is
up.
up,
Minus 2, yeah.
and the answer is minus 2. Yeah. So the solution will be x equals
Minus 2.
minus 2. There's your solution. Alright? Easy then, yeah? Right, so that's how we can use a graph to solve it. However, we're moving on a step now. Right. This time we've got something like this. This time we don't have, we're going to pick this one for instance, we're going to work on it together. So x plus 1 equals 2x minus 1. So we've got x plus 1 equals 2x minus 1. So here's the thing. We no longer have x plus 1 equals a number. We have x plus 1 equals another line. Alright? So, just to show you, on the graph, right, let me get rid of this, it's rubbish.
So
I'm going to do another equation. And what other equation? So if that's x plus 1, the other line is, what did I say?
y.
So I'm looking at doing, I've got
X
y equals x plus 1. The other line I need to draw is
2x minus
2x minus 1. So let's draw y equals 2x minus 1. Right? So, what do you notice about the two lines?
They intersect.
They intersect. Right? I'm just going to copy that and we'll move it back over here because it's nice and easy. So, here it is. So, if I ask you now, using the graph, where do you think the solution for x plus 1 equals 2x minus 1 is?
Oh, y equals. Oh no. Do we have to give you the coordinate?
You can give me the
Or the
coordinate.
function.
Or what's the solution? So when I say solve, x plus 1 equals 2x minus 1,
Yeah.
using graphs, what do you think it means?
Coordinates.
Well, what did we do for the other ones when I said solve x plus 1 equals 5? What did you have to give me?
Oh yeah, you found the coordinate.
But only the
X coordinate.
x coordinate. So when I say solve, what I mean is, what is x? X is what?
Yeah, 3.
Okay, so what we do is we find this point. Why that point? Yeah?
Because you always do x and then y.
Yeah, but why have I,
X is
to solve this, why have I picked that point?
Because it's where they intersect.
It's where they cross, it's where they're equal to each other. So the solution is what? X equals
X equals
2.
2. We go from that point down There is the solution. Now the fact that y equals 3, okay, so y does equal 3, okay, like that, that is not actually what I'm interested in. I'm only really interested in the 2. So the answer is x equals 2. If I want to then find out what y is, I can, because 2 plus 1 equals 3, and 2 times 2 minus 1 equals 4 minus 1 makes 3. So we know it's 3. All I'm really interested in is what is x. X is 2, x is 2. So when I say solve, I'm asking you to find me the x. Yeah?
But how do you know like it was the red line, like the one that when you did what was
That was x plus 1 that we drew, yeah? So what we'll do is we'll do another one together. So we'll do 2x plus 4 equals 3x minus 1. Okay? Can you remember that?
I'll remember 2x plus 4.
I remember equals 3x minus 1.
Okay. What we're going to do then, to solve that, let's do a new graph. So the equation. What equation should I put in first? Y equals?
Y equals 2x plus 4.
2x plus 4. Okay.
And that's the one we have.
That's one line.
And
Okay.
Equals
And that equals y equals
3x minus 1.
3x minus 1. Okay. What's the problem?
They're not parallel.
They don't cross only on the screen. But what I'm going to do, if I go all the way up here, look, they do cross now. Alright. So, I'm going to take this page, I'm going to copy the graph, I'm going to put it here. Alright. And so what did I have to say we were trying to solve?
2x plus 4.
So solve 2x plus 4 equals 3x minus 1. So what's the solution then? X equals 5. Because
they meet at 5.
Because they meet here at 5. Okay? Easy then, yeah?
Yes.
So when we have a graph, it's really easy. However, that's not exactly what we want to be able to just do. Because we want to be able to do it graphically, but what do we also want to be able to do? Solve it without the graph.
Mentally.
Well, algebraically we call it. So what we're going to do is we're going to use both of these where we know the answers, and I'm going to go through how to solve it if we don't have the graph. Are you happy how you both know, all three of you know how to draw a graph, don't you, of 2x minus 1 and x plus 1? No problem, yeah? Gradient, intercept, all that kind of thing. If you can find where they cross, really easy, yeah? So there's always one way for you, and we'll have a bit of practice. But let's have a look at doing it algebraically. So let's have a look at x plus 1 equals 2x minus 1. We're going to do it algebraically. Now we're going to use exactly the same method that we used when we had equaled a number. But it's not so easy to kind of understand what you're going to do. Well, we'll do it together and then you can write it down afterwards. Okay. So, any ideas what you think we need to do? So we need to end up with just x equals something. And I'm telling you, we're using the same method we did before. So what would you go for?
I don't know if it's right. I'm just...
Yeah, no, go for it. Any go.
Because it says x plus 1, maybe x is 1. So you would do...
Oh, but you're doing a guess method again. Like you tried to do with the other ones, a trial and error method, which takes you a long time. We need a method. Now, I'll tell you what I want to do. What we want to do is we want to eliminate, okay, eliminate terms, just like we did when we were solving the other ones. So what I'm going to try and do first is I want only x equals a number on one side. So this is what I'm going to do first. I don't want this x on this side. I don't want it. How do you get rid of an x on that side?
Well, on the other side, you write +1.
No, how do I get rid of an x?
You rub it out.
I can't just rub it out.
You have to put it on
Mathematically,
the other side.
we don't put anything on the other side.
You
Remember
do the
we've
same
done-
on the
You
other
add
side.
it to the other side.
No, what do we have to do? We've got an x. How do I make that nothing? Mathematically, not just.
Oh,
Phys-
+1.
No. But how do I make it like that?
Minus
Minus what? Not 1.
2.
x.
Minus x. What if I subtract x from both sides?
Then it would be
What am I left with here?
+1.
So 1
Oh, right.
equals.
1 equals 2.
No.
2 minus 1.
1.
2 x's take away 1x is 1x.
So x equals
And I've
1?
still got minus 1 there. Still.
If you take away the 1s,
X equals 2.
What do? I've got now it's a situation you know. It's x minus 1 equals 1. So what do I do now? I want x equals. So same thing we've done before. What do you have to do here? You have to
add
add 1. Good. So if we add 1 to both sides, we get x, because that's gone, equals 2. Which
Wait, isn't it x
is
equals
the solution.
No, isn't it x equals 2?
Whoa, that was
Same thing, isn't it?
complicated.
2 equals x,
No,
x
no.
equals 2.
That's very complicated.
No, I don't get how you count the
I
x.
don't understand how you.
How do you count it? What do you mean?
How you kept the x in the second time.
Because this is x. Right, another way. What is 2x?
2x is
2x.
yeah 2x.
So it's another way of saying is x
X
add
plus-
x minus 1, yeah?
Or 2 or 2
Two.
no or x and then 2.
No,
to
that'd
the
be
power of 2.
times. It's x add x because this is 2
Oh right.
times x, yeah? So if I subtract an x from this x, I end up with just the 1. But if I've got x add x, take away an x,
Oh, you get
I'm left with 1x. I'm not left with the 2, because that 2, as we've said before, means 2 times x. It doesn't mean 2. Yeah? So I'm left on this side with an x minus 1. Yeah? Let's have a go, before you write, at the next one. So we've got 2x plus 4 equals 3x minus 1. Right. Now, there's lots of correct methods, lots of correct things to do first. As long as you abide by the rules of whatever I do to one side, I do to the other, it doesn't matter how quickly we get to the answer, we just have to get there. So, what would you like to do to both sides
Take
first?
away x.
You want to take away an x. Just one x? Should we
Or
take away?
2x
2
and the
because
3x.
yeah. Take away 2
Take away 2 x's, yeah? Okay, why?
because the other side has 3x.
Okay, so I can get rid of 2 x's here and get rid of 2 x's here.
Well, why 2x 3x on the other side?
Ah, but I've only got 2x. Remember, I want to leave x's on just one side. So what Millie said was, let's get rid of the 2x here. And the same, whatever I do to this side. So what is 2x take 2x?
0
0. So I'm left with
plus 4.
just the 4.
And then it equals
And this side,
1.
3 x's take away 2 x's is
1x
1x. And
minus 1.
now what do I do?
You take
Add the
away
1.
the
Add the 1, remember that.
Which makes-
Add the 1 to both sides, which makes x equals 5.
Wait, how is the other side 5 too? Minus 1 plus 1.
Because that's 0 then, yeah?
Oh yeah.
So I'm left with just the x. And 4 plus 1 makes 5. And if we remember from the graph, it's 5.
I still don't get it.
No? What part don't you get?
like the first step, like that you take away. Well, I do get it. It's just like has to get in my mind.
Yeah, fair. I tell you what. Why don't you have a go algebraically at doing the next one? Let's have a look what it is. So have a go at doing 7x minus 2 equals 5x plus 6. Have a go at that one, just algebraically, yourself. Okay.